I'm sorry? I'm sorry, I missed the proof of
concept. Would you still work, was the question.
Here, I'll answer this. So what he's referring to is, my first demos in DNS involved streaming audio and eventually video over DNS, just because it was
just for fun.
It was fun. Yeah. Once upon a time, this stuff was just fun and games, and then it got a little more serious. I will say this. So I haven't done the work that Sandy has in building recursive servers, and clearly the recursive load is increasing in DNSSEC. From an authoritative perspective, it's not just hardware that's gotten ridiculously more efficient. The kernel. So when I did my first talk at Black Hat, I'm like, man, these kernels are so slow. I'm just going to generate the packets myself. Yeah, so kernels are good now. Ended up writing a very small lib event-based DNSSEC server. So what was it, 60,000 queries per second used to be all that VeriSign used to do? Yeah, so you could do 60,000 queries per second on one server and this is what's significant, it's not like you gotta be a genius to write it, in like a couple hundred lines of code. So we live in a different world of available performance and importantly, than even DNSSEC itself was originally conceived of.
So just to sort of throw out some real metrics from what we've actually seen from what's been deployed thus far. About 50% of the queries to the servers today are asking for an extended response. And those responses are about 4 times larger than they were before. So it's about doubling of the bandwidth itself. We haven't seen a significant increase in the query volume, in other words, the numbers of queries per second that we've seen, but we have seen it go up on the TCP side, and a lot of it has to do with the fact that just depends on how different devices handle fragmentation or those sorts of things. But by and large, with the extensions to the length of the DNS packet, you got to remember that 5 years ago, 512 bytes was it. That was it. And so streaming South Park, you had to jam it into a bunch of small packets. But now we have much larger packets, and fragmentation's allowed and those sorts of things, which isn't. Yeah. Now we can go HD. So, but of course the bandwidth's going to go up, and of course the load's going to go up on the servers. Get over it. It is, okay, and that's. You just have to face it. DNS load in general, with or without DNSSEC, was going to go up one way or another. Now it's just going up in a different way. But the other things will still drive load as well, and I think we still have to be prepared for that. And that's what I said earlier in my opening remarks, was that DNS is an interesting protocol. DNSSEC is even more interesting because of the possibility it allows DNS to do other than just serve up an IP address for a domain name.
My question is probably a little weird. I run a closed network lab for testing purposes. In that lab, I had to emulate the roots. This sounds like it would be pretty difficult for me to emulate this in a closed, secured lab where I'm testing malware. Has someone thought of how I could replicate this for malware forensics?
I am kind of, only reason I'm grabbing the mic is because yes, like that's been a quiet little thing that's been in the background. Like, how do we actually support these closed chunks? And you have some issues if you're trying to hijack the namespaces that you don't control. But if you do control the namespaces, you can basically make a stub emulation of those namespaces and then bring them into your own root. If you don't do that, then anything that's a validator does in fact need to be modified to validate against you and not against the real root.
But it's certainly the case. I mean, if you do the stub trick, I mean, all of the servers basically have a way to set up a trust anchor for the thing that is what you're looking for. So that's something that most of the resolvers have.
Anyone else want to pick that one up? Otherwise, there's...
I think so. There's some people with long-standing questions back there. There's a guy in purple who has
There's
given
a man
up.
in green.
And a guy in green.
And others. Send the proctor running. Sneaker net.
Just to your left.
I was just wondering, there's been a lot of talk of how the servers work and how the endpoint resolvers work, but what are the implications of the client tier here? And how are these errors going to get propagated up to the users, especially on systems that may not be the latest, greatest patch levels or anything else?
So there are two philosophies. One philosophy is, you know what, you let your recursive server do the work and maybe some information gets back to the client and maybe not. And the other philosophy is end-to-end trust is awesome and anything that is not end-to-end trust doesn't matter. Not to disrespect the former, I'm a fan of the latter approach. The way that we sort of see things moving is the actual certificate verification engines are going to be updated to validate against DNSSEC. So when the client is actually trying to be secure, before it was using the certificate authority system, which worked as best it could. Now it's going to be able to use DNSSEC. And the nice thing about this is this aspect of the API subset has inherent in it handlers for, hey, before it was the certificate is bad. Now it's, hey, the DNSSEC trust chain is bad. So you end up being able to leverage the existing infrastructure. There is some value, I mean, not even some value, there's definitely value in validating when available the non-cryptographic trust information, so IP addresses and whatnot. I mean, this is great for recursors, it stops cache poisoning attacks and so on. But where the meat of the value is in making certificate validation work more reliably.
But you think that's going to happen on the client, right? The validation is going to happen on the client rather than on the recursive servers.
I think the recursive servers still need to do validation so that we get the comprehensive fix for cache poisoning attacks. But you know, I love Starbucks. I think their coffee is great. I'm not trusting a bit in a DNS reply to tell me, oh, by the way, this is the certificate for your bank.
I mean, another answer, yes, that's absolutely right. But another answer to your question is that for those older systems, the former method that Dan was talking about will still provide value. It just won't provide the last mile of value that he was just describing. And I don't know, I'd be interested in getting other people's idea as to whether they think that that former model will get implemented first, followed by the latter model, or whether we'll just go straight to the end-to-end solution sooner rather than later.
I think there's no doubt that the former is going to have to get implemented first, just simply because that's the only path we have at the very moment for a lot of it. The client software that appears in operating systems and becomes the default thing that you use, they're going to get upgraded. They're going to get updated throughout time, and I think that you'll see the browsers will start to look for that DNSSEC response and start to inform you in a different way. But up until now, it wasn't even possible for that stuff to even provide any feedback to you whatsoever, because there was no core mechanism to enable it. Until DNSSEC was implemented on the root, it wasn't even possible to broadly deploy DNSSEC outside of closed labs. It just wasn't possible, because without a chain of trust, you know, some people tried, and I think, you know, we all have varying degrees of experience with those and how successful that they were. But finally, we've actually started something now that will enable those client applications to have something that they can use. Until they do, I mean, why would you put it into the Internet Explorer if there's no protocol to read yet? And everyone at the time was talking like DNSSEC was still another 5 or 10 years down the road. Remember, DNSSEC's been a protocol, if you will, or an extension to the protocol for a dozen years. And it's just taken that long to roll out.
So just as a note, yeah, we're going to release end-to-end client DNS validation logic in like a couple hours. So this game is on.
With recursive name servers moving towards DNSSEC and that whole model, that still requires the client to trust the recursive server, and the panacea is that the client will actually do end-to-end trust as well. Do you have any feel for what the major vendors are doing, like the Suns, the Apples, the Microsofts of the world, what they're doing in terms of incorporating DNSSEC into the end node operating system so that the application layers can make use of that?
It's not going to start at the APIs. It's going to start in the end applications and then move into the operating systems. That's just kind of the path of innovation now. So it's going to start with the browsers. It's going to start with the desktop applications. It's going to start with the actual code. Instead of calling into the operating system, calling into LDNS, writing the 8 lines of code it takes to do an end-to-end resolve, and using the trusted value from there. That's kind of the path that I see. And then, assuming this becomes popular, then yeah, we'll see operating system level support somewhere down the line. But the flexibility of the end applications is much higher than the flexibility of the operating system, which are just on much longer timelines.
And I'll just add, there's a number of speakers in the program over the next few days from those firms, and you might want to be asking them when they're up on stage what their plans and their timeframes are, because they're in the position to authoritatively answer those questions.
With V6 on the near horizon, what sort of challenges, considerations do you see for people migrating to that in the next little bit?
The V6, I'll speak to it very briefly, and then Ken can maybe pick up on that. The fundamental infrastructure's in place there. The DNS supports IPv6. Allocations are being made by ANA to the regional internet registries, who are then allocating it to their members and users. So IPv6 is available, and it's really time to see some killer apps and driving adoption, and of course scarcity of IPv4 will help drive adoption as well. And with that, I'll hand it over to Ken.
Actually, IPv6 is one of the few extensions to the internet protocols that actually most of the infrastructure is already there into the operating systems. So I think all of the major operating systems today support IPv6, at least the modern versions of them. The DNS system supports IPv6. In fact, there are root servers and top-level domain servers on IPv6 networks today. I don't know of many registries that don't accept DNS or IPv6 registrations today. So most of that's in place. It's now in the hands of the ISPs to deploy networks that are actually IPv6. And I think that the challenge there are twofold and not completely different than those from DNSSEC. And that is, one, do all of the firewalls, load balancers, et cetera, that are in the path support IPv6, or do you have to keep toggling back and forth between IPv4 and IPv6, which some of the earliest implementations of IPv6 today, where people are implementing IPv6, they do have to sort of translate back and forth inside their network to IPv4, and in some cases tunnel the IPv6 over IPv4. Those things are going to exist, but the great thing about it is that possibility exists that we could even do that, where with DNSSEC, almost none of the prep work had been done at the operating system level, at the router level, at the firewall level for all of this until 2.5, 3 years ago when it looked like DNSSEC was catching momentum. So I think as the ISPs roll it out, I think everyone's going to be ready for it, because the IANA can assign IPv6 address blocks today. I mean, you could get one today if you wanted. The DNS system supports it. The operating systems support it. So I think we're actually in better shape with IPv6